Okay, hi everybody. Here's homework problem number 29, and this is a trinomial, and we're going to try to factor it. Now, the first thing you should do is look to see if there's a greatest common factor. So 15, 24, and 8. Do they have a common factor? No, just 1. Nothing greater than 1. And then there's a p squared and a p, but there's no p on the last one. So there's no greatest common factor. So now we're left with trying to factor this into two binomials. And we want the first two numbers to multiply to give us 15p squared. So there are some choices like 3p and 5p, 15p and 1p. And then we have choices as to which one we put where. And then for the last two numbers, they need to multiply to give us 8. So we have some choices 8 and 1, 2 and 4, and then we would have to choose which one we put where. And when it's all said and done, when we calculate the inside product plus the outside product, it has to give us 24p. So there's a lot of kind of fiddling around to do, and we don't even know if it's possible. So let me tell you, there was a question that came up. How do I even know if it's prime? So prime is the word that your book is using for not factorable. There is a shortcut for knowing if something is factorable or prime, and that shortcut relates to the quadratic formula. Now, I'm not going to go into all the detail of why this works, but once we get to the quadratic formula when we're reviewing that part of last year's content, we can go over that in a little bit more detail. But if you recall from the quadratic formula, the inside of the radical is b squared minus 4ac. In fact, that part's given a special name. It's called the discriminant. So we have a quadratic expression here. If we calculate the discriminant, and if the discriminant is a perfect square, we have something that's factorable. If it's not a perfect square, we have something that's not factorable, so something that's prime. So what I'm going to do is calculate the discriminant for this problem. So b squared minus 4ac is 24 squared minus 4 times 15 times 8, and that works out to be 96. 96 is not a perfect square. So this means that we have something that's not factorable, so our answer is just going to be prime. Now, you don't have to do it that way, but your other choice is to exhaust all the possibilities where you're going like this. 3p plus 2, 5p plus 4. And you check the insides and the outsides, and uh-oh, they don't add up to 24. Okay, it's not that. 5p plus 2 times 3p plus 4. And you check the insides and the outsides, and they don't add up to 24, so it's not that. And then you do 3p plus 1 and 5p plus 8, and you check the insides and outsides, and it doesn't add up to 24, and you do that through all the possibilities. It's not like there's that many possibilities, but it would be pretty easy to lose track and miss out on something and just not feel very confident about it. So I recommend giving this method a try with the discriminant, and it might save you a little time and give you a little more confidence. Thanks.